Okay, so we have a test tomorrow. So group A is taking the test tomorrow here in class. Group B will be taking the test in class on Wednesday. And I will email group B to make sure, and those of you guys that are online, you are not allowed to access the test tomorrow. So the window for the test will open tomorrow during third period so that group A can take it. But if anybody from group B accesses the test from home, you will get a 0. Okay, so if you are home, this is group B. Group A, it won't matter because you guys will already have taken it. But group B, if you guys access the test from home, then you will not be able to take it. Okay, so do not click on the test. Do not do anything with the test. Don't go on the AP Classroom and try to look at the test. Okay, and then group A, oh, there's Jordan. Cool. So since we are taking a test that is based off of AP style questions, that means you can expect the test to be curved in some way. And the curve will be determined between our two cohorts here and Mrs. Lovett's as well. So group A people that are taking the test tomorrow, please do not discuss it in any way with group B. One, it's not ethical to do that. And two, you guys would only be hurting yourselves. So if group B ends up doing better than you guys because you discussed it with them, all that's going to do is hurt your grades. And group B, please do not ask. Okay, don't put group A in an awkward position to ask them to do something that's unethical. Yes. Yes. So the test is going to have 10 multiple choice, all from unit 3, and 10 free response, kind of like this kind of thing from unit 3. So there will not be any unit 1 or unit 2 material on the test. So it will be all unit 3, but that's what you will see is 10 multiple choice and 2 free response. So if you figure free response is supposed to take, maximum 15 minutes, probably more like, 10 to 12 minutes reality. That's what the free response is going to be. And then that gives you plenty of time to do 10 multiple choice. Yeah. Yeah. Mm-hmm. Okay, there is a review sheet on Schoology that I posted. There is a practice test on Schoology that I posted. It does have some unit 1 and 2 review material, but if you don't want to focus on those, that's fine, but it's got a lot of unit 3 material. And the answer keys are also on Schoology, so I would look at those. You can still look at Pearson. I didn't create a study guide since we're not taking the test on Pearson, but there are still practice tests for every unit. So if you wanted to go through and look at practice quizzes for the different chapters, you could. But I would really focus on the review material that's on Schoology, and, of course, the personal progress checks that you guys did. I graded personal progress check free response. I graded group A's. I did not grade group B's yet, but since group A is here and taking the test first, I wanted to get your guys' stuff graded. And then today I will finish by grading group B's free response. Free response. And I know that in order for me to actually get the whole thing on the screen, it gets really, really small. So I'm just going to make it small and I will read it and then I will zoom it out again so we can actually see it. So it says researchers are investigating whether people who exercise with a training partner have a greater increase on average in targeted exercise intensity compared with people who exercise alone. 2 methods of collecting data have been proposed. Okay, so we're trying to see whether exercising with a partner can increase the intensity of the exercise. So I would imagine the idea is if you're exercising with someone, you guys are encouraging each other to, really do a good job at exercising and not to be, taking it too easy. It's a lot easier to do that when you're by yourself. If you guys have ever like watched a, aerobics video at home and you're there all by yourself, it's really easy to say, yeah, that's enough, I quit. But when you're in an aerobics class at a gym, it's easy to just say, I give up and quit, because everybody watches you give up and quit. So there's a certain amount of, peer pressure when you're working out with someone. So the idea here is we want to know whether that is associated with an increase in the intensity of the exercise if you're actually working with someone. So the way that they're going to figure this out, method one, they're going to recruit volunteers who are willing to participate. And then they are going to randomly assign each participant to exercise with a training partner or to exercise alone. So that's the first option of how to get this data about exercising with a partner versus alone. Method two, select a random sample of people from all the people who exercise at a community fitness center, and then ask each person in the sample whether they use a training partner, and then use their response to create the two groups. Okay? Now, part A says for each method, the researchers will record the change in the targeted exercise intensity for each person in the investigation, and they will compare with the ones that used a partner versus those that did not. Okay, so first question says, describe the population of generalization if method one is used. So method one, they recruit volunteers who are willing to participate, and then they randomly assign each participant to either exercise with a partner or to exercise alone. But our focus on this first question is, who is the population? Okay? And the population has to do with where are these people coming from? Okay? They are volunteers. So where are these volunteers being selected from? So how do you think they're even finding out about this? I mean, I don't know for sure, doesn't say. But I would say that our population is everybody who could volunteer. They hear about this program and they're given the option to volunteer. The volunteers come from the larger population of everybody who is capable of volunteering. Okay? Not everybody will volunteer, but our population, where are these people coming from? They're coming from the larger pool of people that could be theoretical volunteers. So whether it's, they put an ad in the paper, I have no idea, but our population is anybody who is, capable of volunteering because, they get the information or whatever. So the volunteers are coming from that larger group of people that could volunteer. Now, of course, not all of them volunteer. We only got some volunteers, but that's who our population is. Method two, who's our population? This one's easier. It tells you right here where the people are coming from. So we took a random sample from all the people who exercise at a community fitness center. That is our population. All the people who exercise at this community center is the population, because that's where the people came from. We took a random sample from all the people who exercise at this particular community fitness center. Okay, so a random sample, or any kind of sample, however it is getting generated, volunteer, random sample, whatever, it does come from a larger population. It's the population that we're hopefully trying to generalize to. Problem with volunteers is, yeah, you can only generalize to the people who would volunteer or who are very similar to these volunteers. So that's the problem with volunteers, it's bias. And the random sample should be unbiased if it's a random sample. Okay, but all they're asking on part A is to describe the population. Okay, so describe who we are taking these people from. And part B. Okay, Suppose the investigation, I know I can't do this for here, so I'm gonna do this. Suppose the investigation produces a result that is statistically significant. Statistically significant means that they see differences. They see a difference between people that exercise with a partner compared to people who exercise alone. And the difference is large enough, that's what statistically significant is, that we don't think it was just random chance. Something is going on. It's not just random chance, okay? So both of these methods gave us statistically significant results. What can be concluded using method 1 that cannot be concluded if method 2 is used? So now we're looking at our conclusions. So method 1, volunteers. Method 2, a random sample. But if we keep reading, these volunteers were randomly assigned. And method 2, the random sample, was just, they were asked whether they like to exercise with a partner or whether they tend to exercise alone. So besides the volunteer versus the random sample, what is also the difference between these two methods? What is method 1 actually? So what does it become when you randomly assign people to something? Starts with an E. What is this? It's an experiment. When as soon as you randomly assign people, this is an experiment. Okay? The second one is not an experiment. Nobody was randomly assigned to, hey, you're going to be a part of this study, so we're going to make you, by random assignment, we're going to have you exercise for the next month with a partner. The second one was all choice. They were just asked whether they tend to exercise with a partner or not. So this is an observational study. Okay, so just keeping that in mind, that's really the main difference between these two methods. Yeah, there's also a difference in where the people came from, but the most important difference is method 1 is an experiment, method 2 is an observational study. So what can be concluded with method 1, the experiment, that you cannot conclude from an observational study? So what is it that we can conclude from an experiment? Key thing that we love to be able to conclude if we can. Ooh, what was that? Okay. Experiments. Very important that you know this. An experiment can give you cause and effect. So method number 1, you can conclude cause and effect. Specifically, you can conclude that training and exercising with a partner does lead to more intense exercise. It's an experiment. So you can conclude that training, because that was our explanatory variable, was training with a partner versus alone. We can conclude that training with a partner does lead to more intensive exercise. Okay, we cannot conclude that with method 2 because it was an observational study. We have no way of knowing whether people that like to exercise intensively tend to choose partners or whether there's something else going on. We have no way of knowing. We do know that there's a significant, statistically significant difference, but with an observational study, we don't know why. We have no way of knowing what's causing the differences. With an experiment, if it's well controlled, we know what's causing the difference. It's the explanatory variable. Now, it does say to explain why. So to explain your answer, why can we say training with a partner in method 1 would lead to more intensive exercise? The reason we can do this is because the participants were randomly assigned. That's the reason can do this with an experiment. So we're randomly assigned, and I'm running out of room here to work out with a partner, or alone. That's the reason. Okay, and a lot of you guys did not explain that well. So it did say why. Method 1 is an experiment, and that's great. You could say it's an experiment, but you still have to explain why. Why does an experiment allow you to use cause and effect? It's because the participants in the experiment are randomly assigned to their treatments. That's what makes an experiment allowed to use cause and effect. With an observational study, we have no way of saying cause and effect. All we can say is that, hey, there's a statistical significant difference between the two groups, but I got no way of knowing why. So we can still see things that are statistically significant, but we cannot make a conclusion of why. With an experiment, we can. With the experiment, the why is, oh, because we randomly assign them to the two different groups. So the working with a partner obviously affects the intensity of the exercise. Okay, so that's one of the main reasons experiments are superior to observational studies when you can do them. Okay, this question was about a survey given to a random sample of 400 people living in a certain community. People were asked whether they supported the construction of walking trails in the community park. The results are shown in the table. So you can see that there's a strong support of putting walking trails in the community park. So 210 said yes, they would support it. 90 do not support it. 100 had no opinion, and they asked 400 people here. Now, some of you guys when you turned it in, said that you couldn't figure out how to get it to draw on here. So obviously that's not a big deal, as long as you do know how to do your segmented bar graph here. But what you would do here is you would take each one of these categories and convert it to a percent. So 210 out of 400. So if we did, whoops, 210 out of 400, that is 52.5%. So then you would go to your bar graph. Oh, it's in decimal form, so I'll just be more exact and not put a percentage there. This is 0.525. Same value. Now come over here, 0.525. So that's probably about right here. And then if you had the ability to do colors, fine, but if not, I can just draw something like this. And then on my key over here, I would say that those lines going that way are the people that responded yes. And then the no's, there were 90 out of 400. So 90 out of 400 is 0.225. So I'm going to add that to my 0.525, and that takes me up to 0.75. So there's my next group right here. And I don't know, I'll just color this all in. You just have to have something to tell which segment is which. So this would be the people that said no, and then that leaves the top, the no opinion. Okay, so that's just really rough sketch there. So, and I know some of you guys, like I said, when I was grading them, said you couldn't figure out how to draw it on there. But just as long as you know that that's what it would look like. So the largest group down there, the people who agreed that wanted the walking trails, and then you have the no that does not support it, and then you have the no opinion. The do not support and the no opinion were very close in size. So you'll see that there. Yeah. Now, here's where it got a little tricky. A follow-up study is going to be conducted. We're going to take a sample of 200 people. From the 300 people who responded yes or no. So in other words, we're now going to take another smaller sample, but we're only going to be taking our sample from these people right here. So that is our population now. So this is our population. Everybody who responded the first time, either yes or no. We don't care about the people who don't have an opinion. We only want to be surveying the people who had an opinion. But we are now going to take a sample of 20 out of these two groups here. And notice that now that we're not including these people, now our population has a total of 300 because we're not including the no opinion people. Okay, so we're going to take a sample of size 20 from those people. And where did my question go? There it is. Okay, two sampling methods have been proposed. We could just take a simple random sample. That would be number the people 1 to 300, use a random number generator to generate 20 numbers from 1 to 300 with no repeats, or you could say without replacement. That's another way of saying no repeats. And then whatever 20 numbers come up, you go to those people and they are now part of your sample, okay? Or a stratified random sample. So a stratified random sample with using survey response as strata. So a stratified would mean that we take a sample from the ones that support. So we're going to take a sample from here, and we're also going to take a sample from here. So we're going to take some from the yellow group, some from the pink group. Now, if we really want this to accurately represent our population, that is our population, do you think we should take 10 and 10? No, that would way over-represent the ones that do not support. Look at how much lower our population is of the ones that do not support. So even though technically it's still a stratified sample, if you do that, it just would be a kind of biased one. It would not be representative of the population. In order to represent the population, we really want to look at our proportions here. 210 out of 300, we really want 70% of our sample to be from the yellow group, and then we want 30% to be from the pink group, because that's 210 out of 300, okay? So that was really what it's asking. How many should we take from the yellow group? So if the stratified random sample is used, what is the number of people that will be selected from those who responded yes? So we had 210 out of 300 that responded yes, which is 0.7. So that means 70% of our sample should be from the people that did yes. So we should do 0.7 times our sample size of 20 equals 14. So select 14 from those that said yes. And it's had to show your work, and as long as we can tell what you did, that is showing your work. And I think you can tell what I did. I took 210, I divided by 300, I got 0.7, which is 70%, multiply that by my sample size to figure out that I should get 14. So I should get 14 from the yes group, and I should get 6 from the no group, okay? And then here, describe a statistical advantage for using stratified versus a simple random sample. So what is the advantage of stratifying here? What does stratifying do for us? So why do it? Yeah. Good. Okay. Is it theoretically possible that I could take a simple random sample, theoretically, could the entire sample, all 20 in my sample, come from the yes group? Could that theoretically happen? Yeah. Would that be a good random sample? Doesn't mean I did anything wrong, but that could theoretically happen. Probably unlikely that you'd get all 20 from the no group because the no group is so much smaller, but it could happen that you get all yeses, or just a very large proportion of yeses, way more than the 70% that we should have. So that's really the advantage of stratifying. If you stratify, you can set up proportions wise and make your sample follow the same proportion as the population. So I know that my sample, based on how they told us to set it up here, I'm going to have 70% in my sample of people who said yes the first time, and I'm going to have 30% that said no, just like I did in the original population. So my sample is going to mimic the population. It's going to have the same proportions of yes and no as my population. Now, a lot of you guys said on here that you would have equal representation from the yes and the no. Do we have equal representation? No. And I know what you guys meant. You guys meant equal as in the sense that it's fair or it's the way that it should be. But be careful. Equal in math means equal. Equal means exactly the same. Equal would mean that we're going to stratify this and take 10 from each group. And that would not be a good way to stratify. Okay? We should stratify by taking 14 from the yes group and 6 from the no group so that we mimic the proportions of yes and no from the population. So we would want our sample to mimic what we know is true in our population based on what they answered the first time they took this survey. So just be careful. Don't say things are equal unless they're equal. Don't say things are normal unless you're literally talking about a normal curve. Okay, so things in stats are not normal unless you're specifically talking about a unimodal bell-shaped curve that we know follows a normal model. So normal doesn't mean, you know, it's not unusual. Okay, I know normal can mean that in other classes, but that means something very specific. Okay, so just make sure you are using your words precisely. Okay, because I did have a lot going through of the ones I've graded so far that said that. It will give equal representation of both groups, and that's not what we're looking for. We're looking for the representation to be proportional, to be appropriate, to represent the proportions that are in the population. So the stratified guarantee it will represent the population in way of those proportions. Okay. So unit 3. Oops. I'm going to let you guys work on what you need to work on, but I want to make sure that you know that in unit 3, okay, we had chapter 10, which was on simulations. We didn't do a whole lot on simulations, but for a simulation, you need to make sure that you can read through a simulation that's described and say, yeah, that's the correct way to do it. So you need to make sure that you can assign the appropriate number of digits. You know, whether it's a table or flipping a coin, whatever it is, you just have to make sure that the way that you're assigning things is appropriate. So if I say somebody free throw basketball, that was on one of our stats medic, has a 70% shooting rate at the free throw line, we can use the numbers 0 through 9. Just make sure 7 of the numbers represent he makes the basket because he's a 70% shooter. And then 30% of the digits should represent that he's not. So in other words, you would not flip a coin for that because he's not a 50-50 shooter. If he's a 70% shooter, you need to make sure that the way you assign the representation for your simulation actually represents 70 and 30%, okay? So with simulations, that's pretty much what you need to be able to do is just read a simulation and know which is the correct way to assign the digits or to be able to say, no, they did it wrong and explain why they did it wrong. We didn't do a whole lot with chapter 10 and AP exam doesn't do a whole lot with chapter 10 with simulations either, just as long as you can kind of read and understand what a simulation is doing. It's trying to simulate a long-term probability that might be too difficult to calculate on its own. But chapter 11 is very important. This is sampling. So we have simple random samples. We have stratified. We have cluster. And we have systematic. Okay, so make sure you know the difference between all of those. They are all random, so these are all unbiased. That means they're all fine. So unbiased means that they are all fine ways to estimate something. However, sometimes one is better than the other, like in the free response we just looked at, a stratified for the yeses and the nos would probably give us a more precise estimate than a simple random sample. Because with the simple random sample, we might get our proportions completely off. So sometimes stratified might be better than a simple random sample. Cluster is usually easier, but there's a lot of times where it's not good. Like I would not do a cluster sample with this. You know, I got my people divided up into two clusters, the yes cluster and the no cluster. I'm just going to choose one. That would not be good, because then you would literally get everybody with the same opinion, and that would not be a good random sample. Okay, so make sure you understand the difference between all of those and think about the advantages versus the disadvantages. Advantages. The writing is bad here. Oh, Nick is joining us. So know about the advantages and the disadvantages for the different types of sampling. You can go back to some of the StatsMedics that we did. We did a whole bunch of different types of sampling in there. And then make sure if there is bias. Explain it and what it might do. Specifically, if you can consider an under versus an overestimate. You remember that warm-up we did with the cafeteria food, where they just asked the first, you know, whatever 100 people that showed up at the cafeteria. We know that it's biased because that's a convenient sample. It's not one of these random samples. Why is it biased? Well, for example, it is feasible to think that the people who show up to the cafeteria as soon as it opens might like the food more than all the other people that are not showing up right when it opens. So I think that there is a good chance that they will overestimate the proportion that like the food in the cafeteria. Okay, so that would be an example of why it's biased, because those people are different than all the other people that were not included, and that might lead to an overestimate, for example. Okay, so that's the main thing from chapter 11 is all the different ways to sample, and recognizing that if you don't use one of those unbiased sampling techniques, you're going to have bias. Sometimes you could still do one of those things, but you might have bias in the way the question is worded. There's other ways that you can have bias as well. But definitely convenient samples are biased. And then that leaves us with chapter 12, which is experimental design. Experimental design. Okay, so make sure you know the difference between an experiment versus an observational study. Okay, the difference is an experiment, the participants are randomly assigned to treatments. Observational study, they are not. Why do we want to do that? Because with an experiment, we can conclude cause and effect. With an observational study, we cannot, because we did not randomly assign the treatments, the participants to treatments. So that's the difference of how you tell which one is which and why experiments can be superior to an observational study. Okay, now with experiments, there are 3 different types. So we've got our completely randomized design. Completely randomized, that's the basic experiment. Okay, we've got the block design. And we also have matched pairs, which is really just a special type of block design. So with matched pairs, you match 2 subjects together because they are similar to each other, or you might match a person with themselves. If it's a treatment that they can do separately, or sometimes it's, you know, you got 2 arms, you can do something on one arm versus the other arm, or something on one foot versus the other foot. So, oops, I didn't put ED there, but that's matched pairs. Okay, so make sure you know, why do we block? The block design, why would we block? Okay, we block to reduce the variation within the treatment groups. And we believe that that variation is there because there's a certain characteristic that is going to affect our response variable. So whatever that response variable is, there's something that is affecting it. So if you remember the SAT prep class, we were looking at whether the online versus the in-class SAT prep class was better. So we could block by the year. Okay, because we thought, hey, you know what? Seniors tend to do better on the SAT than juniors anyway, so we should block by junior versus senior, and then that reduces the variability within each block. So that's why we block. When there's a factor that we think affects the response variable, it is a good idea to block. So make sure you know why we block. And then just remember that every experiment you need to control all outside sources of variation. So you want to make sure there's no confounding factors or confounding variables. So you treat everybody in the experiment exactly the same way, except for the treatment itself. So if you got the shrimp in the tanks, you need to treat them all the same way, except for that one nutrient, same temperature, same, you know, whatever else might affect shrimps. Everything needs to be exactly the same except for the factor that you are testing. And of course, we need to randomize. Okay, we randomize by randomly assigning the treatments to each one of our participants. That's also a way of controlling, because sometimes there's a confounding variable that you might not know is there, and if you don't randomize, you have no way of controlling it. So we control, we randomize, we replicate. Replicate means you got to have more than one person or participant in each treatment group. You don't do a treatment on at least 2 people, and hopefully more than 2. I mean, 2 is not a lot anyway, but you need to replicate. You need to do it on more than one, because otherwise you have no way of knowing what the variability is. There's always going to be variability. And if you only have one person in your treatment group or one participant in your treatment group, you have no way of measuring what the variability is. So the more you have in your treatment group, the better you're going to be able to estimate the variability and therefore reduce the variability, which is what we want to do. And then, well, I'm not going to write blocked on there. Block when it's appropriate. Okay. Also, other tools that we have to help us with this is we use placebos. Placebos can help us control psychosomatic things that happen with people, where they think they're going to get better because they're in this cool experiment and they're being tested on this new drug and they think they're going to get better. So sometimes it's psychosomatic, so we use placebos to help us control that. We also use blinding for very similar reason. So we blind them and not letting them know if they are getting a treatment. Sometimes you can't blind. Sometimes, you know, the treatments don't allow for a placebo, like the exercising with a partner versus not a partner. No way you can put a placebo in there. No way you can blind the participants. They obviously know whether they're working out with a partner or not. So a lot of times it's not possible. But specifically with drugs is when we use the placebo and the double blinding whenever we're doing an experiment on a new drug, for example. Okay, so that's basically what Unit 3 is about. So it's mostly Chapter 11 and 12 with a teeny little bit of the simulations thrown in there. We just did one day on simulations, but it's really about the different sampling techniques and the experiments. Okay, so we have, when are we out of here? So we got about 20 minutes. You guys have a review sheet on Schoology. You have a practice test on Schoology. You could also go to AP Central. They have every single AP exam for the last 20 years. And I could guarantee you that pretty much every single AP exam has a Unit 3 question on it. Okay, that's something that you can count on when you take the AP exam this May, that one of your 6 questions will be based off of stuff from Unit 3, sampling and experiments. And this is kind of a different type of unit because it's literally all, writing and explaining. And we didn't do any calculations really in this unit at all, unless you count the, random number generator. But we didn't do any calculations. It's all about what is appropriate and not appropriate way to gather the data. So it's kind of an interesting unit because of that. And in some ways, makes this unit easier, but in other ways, it actually makes it harder because it's going to be a lot of explaining. They're going to ask you to explain in detail why something is true. So you got to be really good at being clear in your explanations. Don't say things you don't mean. So read what you wrote and make sure that that's exactly what you meant. Okay? Like, for example, not saying that stratified makes everything equal. It doesn't necessarily make everything equal. If your population is not equal, you wouldn't want your representation in the stratified to be equal. Okay? So does anybody have any questions? Yeah. Like I said, I just want you guys to work on what you need to work on.